Now I can plug that in here with the speed of light to find the wavelength. Okay, so this problem gives us practice with both of those equations. We have wavelength equals c over the frequency. Okay, the speed of light is 3.00 times 10 to the 8th meters per second. This constant would be given to you, although it's not terribly difficult to remember, but with the units and everything, I'll give you that on a test. And then we have the frequency, 6.17 times 10 to the 14th, and then per second. Okay, so you'll notice I have over seconds on the top and over seconds on the bottom, so that part is going to cancel out, and I'll be left with meters. Okay, so here again, I've got a number, two numbers that I'm dividing, both in scientific notation. And so the way this is going to work is 8 minus 14. So I'll have this part and then times 10 to the 8 minus 14, which is negative 6. All right, so and on the calculator, I want to on most calculators you can do this where you refer to the number that we just put in the calculator. We just calculated that 0.617. Here, let me put that in the form that we have it. Okay, 6.17. You can take that instead of rounding it off to 6.17. Okay, if you wanted to, you could say 3.00 divided by 6.173, and if you have at least one more digit, that'll eliminate rounding errors. But I like to just go ahead and use that that value that we just had there. Now, some calculators you might have to use the memory feature where you store it into memory and then you recall it again when you divide. But that will eliminate some rounding errors. On my calculator, I can just do second and then enter, and it pulls that number up from the previous answer. Okay, so if I take 3 divided by 6.17, I get 0.486. Okay, and this is my final answer, so I don't have to worry about the rounding, because I have to round it at some point. But this way, that's the only time. You only want to round once in a calculation if you can avoid it. Okay, if you can avoid any more than that. All right. So if we put this in proper scientific notation, that's where we have the decimal after the first non-zero number, and this will be, let's see, it's going 6 places to the left from here. So now from here it has to go 7 places to the left. Okay, and my units are meters. Right? So this is the wavelength. Okay, now most typically, actually, we wouldn't leave it here. We would write this in units that are more familiar or more useful to us, and that is, we would put them in nanometers. Okay, for visible light, nanometers is quite typical, and what we would do is just, there are, in 1 meter, there are 1 times 10 to the 9th nanometers. Okay, so I'm just moving the decimal place from 7 places forward 9 places, so I'm going to end up with 486 nanometers. And that way I don't have to worry about all this cumbersome scientific notation stuff. Okay, so that is the wavelength of light that has an energy of 4.09 times 10 to the minus 19th joules, right? And it said this came from the hydrogen spectrum, and so this looks like one of the blue lines from that spectrum. It's just a little FYI.